It's just reminding you that v and r and h are functions themselves. So basically what I want to find, dv dt, is the derivative of this side. And since this side equals that side, I can take the derivative of each side with respect to time. Way back in Unit 3, we might have used notation like this to indicate that that's what I'm doing. Remember, this is telling me to take the derivative. This is not a differential itself that I've added. I'm just saying, okay, I'm about to take the derivative on this side and on that side. When I take the derivative of the v function, I'm just going to end up with v prime of t, but this is where I want to switch back to using differentials. V prime of t is the same thing as dv dt. It's just a different notation. If I take the derivative of v of t, I get dv dt. What about on the other side? Since we're thinking about r and h as functions of t, what we really have here is a product rule with a chain rule. Two of them, in fact. We're multiplying this expression times this expression, and then each of these expressions have their own derivatives because they're functions. So all I'm doing is product rule. Make sure you can follow along these steps. U dv is first. Notice how I use differential notation for the derivative of h of t. Now I add v du. And in this case, since the r function is being raised to the second power, I first bring that power in front and drop the exponent and leave the r function where it is. And then I have to multiply it times the derivative of the inside function, which is r of t. The derivative of r of t, we could have written r prime of t, or we can use differential notation and write dr dt. Pause for a minute and make sure that you understand each of the pieces of this expression. Okay, great. Now let's simplify a little bit. Ultimately, we want an expression whose output is dv dt. We've got that. We just need to simplify what we're looking at a little bit over here. And the best way to do that is to recognize that when we say r of t, it's okay to just write r, because the assumption is in order for us to actually get a number answer to this question, we actually need to know what the radius and the height is at the moment when we're trying to calculate the rate of change. So instead of h of t, I'm just going to write h. Instead of r of t, I'm just going to write r, and I'll get a simplified expression. And that's your final answer. Let me quiz you a bit on notation before we do our last example in this lecture. What does dv dt represent? Right, that's how quickly volume is changing. What does r represent? The actual radius. What does dh dt represent? That's how quickly the height is changing, and that's different than dr dt. What's dr dt? Exactly, that's how quickly the radius is changing with respect to time. Gorgeous. So if you can do this much, the actual problems are really no problem, because in an actual related rate question, the only difference is that we have numbers here. As an overall strategy, this is really very similar to all word problems. You need to know what you're looking for, you need to know what you're given, and that means truly understanding what the description is, not just knowing that it says 500 feet. I recommend drawing a diagram. Once you understand what's going on, you start your problem using differential notation. So anything that's given to you that represents a rate should be written as a differential. dv dt, dr dt, something like that. Pick units if you need to. Once you've done that, you're going to identify the missing derivative. Remember, that's kind of like over here where we were trying to figure out what goes in that blank. When you know what the missing derivative is, you're going to write a function that has the correct output and input that you need. For example, in our balloon problem, we needed the output to be the volume and the input to be radius. From there, you're going to use the related rate equation. Typo right here, use. If you want to read about the steps in more detail, page 246 in your textbook has really a very good explanation of how you start this process. Let's do example 4. Go ahead and read this problem and see if you can identify what we're trying to find and draw a diagram of what's going on here. When you press play again, I'll show you what I came up with. So this question probably reminds you a little bit of pre-cal maybe. Hi, Ms. Schaefer. Basically, we're looking for how fast the balloon is rising, and when they say it's rising straight up from a level field, they're telling you that there's a right angle, and you have to really understand that image of going straight up from a flat field. The distance of the rangefinder is going to be basically one of the legs of your right triangle, and they tell you this angle, which is the angle where if you're standing over here, you have to look up to see the balloon. They also tell you the angle is increasing at a rate of 0.14 radian per minute. If we're following along the strategy, we've done step number 1. The next thing we need to do is set up differential notation. Can you interpret both what we're trying to find and what we're given using differential notation? What notation would you use for each of these? Excellent. So how fast the balloon is rising is really talking about how the height is changing with respect to time. So this expression that we're trying to find is really dh dt, where h represents the height of the balloon, which is this distance right here. It's the other leg. Now, this one might be a little trickier. What differential should we use to represent this known information? Here we're talking about the angle. You may have chosen a different variable, but oftentimes we use a theta. And you need to also recognize that when they say the angle is pi over 4, they're telling you what the theta is at a particular moment. And then the rate at which it's increasing is d theta dt. And since they tell us it's 0.14, we would write d theta dt equals 0.14 radians per minute. The next step is to set up a differential equation. What should that look like? Beautiful. dh dt is going to equal something times d theta dt. What should that something be? Right, if this is going to be a true equation, it has to be dh d theta, because the thetas will cancel out and we'll end up with the derivative of h with respect to time. Now for the really important part. What does dh d theta represent as an expression altogether? So this is the true test of whether you understand Leibniz notation. dh d theta is the derivative of a function whose output is height and whose input is the angle theta. Can you look at this diagram and come up with a function that would satisfy those descriptions? So hopefully you remember your trigonometry. This is the opposite side, this is the adjacent side. So if you have this angle, we would use a tangent function and multiply it times the base side. The height, h, equals 500 times the tangent of theta. Now, to find dh d theta, what do I have to do? Right, take the derivative, which is just 500 secant squared. And h prime of theta is really just another way of saying dh d theta. And so that's the expression that goes in the middle right here. And I basically have my answer. The rate of change of the height has to equal 500 times secant squared of the angle times the rate of change of the angle. And so to answer the question, all I need to do is plug in the angle measurement and the rate of change of the angle, which comes out to 140 feet per minute. That's how quickly the balloon is rising. That's basically the process here. Notice how easy the math is. The bulk of your thinking probably is just in setting up these problems. Remember to be creative. This isn't about recognizing right away what you're supposed to do. It's about trying to interpret the words and going back and filling in details and using your common sense. At the end of this video, you should be comfortable recognizing when a question is a related rate question, and particularly how that's different from differential questions, because I know they seem similar. You should be able to set up differential equations using this kind of reasoning, and you should understand the overall process. On your homework quiz, I don't expect you to be able to do the entire problem out. This is our first day on it, but I expect you to have a big picture of what the process is, and then a deep understanding of the concept of rates in calculus. Have a good evening.